Let's look at the second question. We have to evaluate 0 to pi by 2 definite integral with lower limit 0, upper limit pi by 2 log tan x dx. It's an easy question, but of course requires your attention. As usual, we'll be taking the given integral as I and assume this equation as the first equation. As I told you earlier also, that the sixth property, which is 0 to a fx dx is equal to 0 to a f of a minus x dx, is applicable at majority of the cases, in majority of the cases. So here also we will make use of this property. So this property suggests that if we make these changes, means in place of x present in the function, if I write upper limit minus x, it will not change the value of the integral. That's why we have placed an equality sign in between. So if I have assumed this integral as I, so after application of this property, the value of this integral will again continue to remain as I. So here we go. We have 0 to pi upon 2 log tan. Only place to be changes here. In place of x, you write upper limit minus of x dx. So let us simplify it further. We have 0 to pi upon 2 log tan 90 minus x. What we write here is tan 90 minus x, it is cot of x. You should know the formula for tan 90 minus x is cot x. So for 9, you can speak 90 in terms of degrees, you can speak pi upon 2 in terms of radians. So we have cot x here. I assume this equation as second equation. Now as usual, I'll be adding first and the second equations. So adding first equation and second equation. The left hand sides will be added together. I is here and another I is here. So we just need to add the left hand sides together. Likewise, right hand sides will also be added together. We have 0 to pi upon 2 here. Log of tan x dx and plus in the second equation, the right hand side is 0 to pi upon 2 log of cot x dx. Again, you can observe both these integrals, they have common limits of integrations between 0 and pi upon 2. So I will prefer to combine them to bring the integrands under a single integral sign with common limit 0 to pi by 2. We have log tan x plus log cot x dx this way. Now again we'll make use of the log property. Log m plus log n is log of m multiplied by n. So this becomes 0 to pi upon 2. Remember, log will be appearing once only and tan and cot will be multiplied together. So we have tan x multiplied by cot x and this dx remains there. Tan and cot, they are reciprocals of each other. So tan multiplied by cos will give us 1. So what we get is 0 to pi upon 2 log of 1 dx. Now log of 1 is equal to 0. So this log 1 is 0. So which reduces the entire integral to 0. We get 2i is equal to 0. So this implies that I is equal to 0. So the final answer for the integral is 0. So over to the third question now.